Welcome to Covalent and Acid Nomenclature Bootcamp. You went to it last week with Dr. Raj, and this week you get a nice 4 to 8 minute video to recap it all. Covalent bonds are between nonmetals, which can be found on the right side of your periodic table, and acids are formed between hydrogen and a polyatom or anion. There's always a hydrogen. It should be noted that these are different from binary ionic compounds. Covalent bonds have prefixes. These prefixes are determined according to the subscript, which represents how much of the element is in an equation. For example, here you have dioxygen pentasulfide, or O2S5. The di comes from the 2 to the oxygen, and the penta comes from the 5 to the sulfide. As you can see, we have 8 prefixes that we know, and you only use prefixes for covalent bonds. Here's an example problem. You have NO3. It is nitrogen trioxide. You have a tri before oxide because there are 3 of it, and that is the prefix. You do not need to balance out the charges in a covalent bond. In our second example of SO2, you have sulfur, which is on its own, and oxygen second, but because it has the subscript of 2, you put the prefix of di in front, which makes it dioxide. You still have the IDE ending as well for these covalent bonds. It should be noted that the sulfur does not need to have the prefix mono put in front of it because it is the first name in the equation. There are 2 kinds of acids, one that has hydrogen and the second part which does not have oxygen, or hydrogen and the second part that does have oxygen, such as a polyatom or an additional element. Arguably the easiest acid nomenclature form is if there is no oxygen and polyatom. In this case, you simply have hydro blank ic. In the example of HCl, you have hydro, which is the automatic prefix if there is no oxygen and polyatom, chlor for chloride, and ic as the default ending. If it has all of its oxygens and it is a polyatom, then simply take the polyatom name and add ic to the end. That's all you have to do. You don't need the hydro prefix. If it has one more oxygen than the normal polyatom, you add per the polyatom name and ic to the end. If it has one less oxygen than the polyatom should have, you don't have a prefix. You take the polyatom name and add us to the end. And finally, if it has 2 less oxygen, then you simply add hypo, the name of the polyatom, us. Our first example problem is when it has a hydrogen but no oxygen. It is HBr. You have the prefix hydro because it has no oxygen. You have brome because it's Br, which is bromine, so the shortened version of it is brome. And you have ic because that is the ending, because it is conventional and follows the rules for having no oxygen. And the second word is always going to be acid. Regardless of the amount of oxygens it has, it will always be acid. This example problem, it's hydrogen, and the polyatom has all of its oxygen. The problem itself is H2CO3. CO3 is carbonate. First, you have to make sure the charges do match, which they do because hydrogen is a +1 and there's 2, so it's a total charge of +2, and CO3 has a -2, so the 2 and the -2 cancel out. Now, carbonate normally does have CO3, and so because it is regular and has all of its oxygens, you simply add ic to the end. You don't need hydro because you have an oxygen, which disqualifies it, and because it is an acid, you need to put the word acid at the end. Our next example is if the polyatom has one more oxygen, and of course if there's hydrogen to denote it as an acid. Now pay attention to the difference. Normally PO4 or phosphate has 4 oxygen. However, PO5 has a subscript of 5, meaning that there is one more oxygen. which means that it's irregular and can't be the first one. The charges still balance out, which is good. Now, the only difference between when there's one more oxygen and when it's regular, you just add per to the beginning. You still have your main base, which is the shortened phrase, and you have ic at the end. So phosphorate reduces to phosphor, you add ic, and then you have acid as your second word to finish it off. It can be difficult to remember these rules, and we haven't done all of the examples yet. However, if you look attention to the bottom right corner, you will see a handy illustration that can help you. You have normal, ic, plus 1 per blank ic, minus 1 is blank us, and minus 2 is hypo blank us. Or you can always think of Dr. Raj's dance. Our next example is if there's a hydrogen and a polyatom that has one less oxygen. Our example is HNO2. Normally, NO3 should be nitrate, which has a subscript of 3, so it has 3 oxygens. However, in our problem, it only has 2, which means it's missing 1. In this situation, if you can reference the graph at the bottom, if it's minus 1, instead of having an ic ending, you add an us ending. You still have acid, because you always need to have that. So your end result for HNO2 is nitrous acid. Again, the charges balance out. Our next example is when there's a hydrogen and the polyatom is missing 2 oxygens. The problem itself is HClO. Normally, ClO is ClO subscript 3, or chlorate. However, as you can see, it's HClO, which means it only has 1, so there's a difference of 2. The charges balance out in this case. Now, the only thing you have to realize about this is that it's similar to the minus 1, where it has an us ending, but because it's minus 2, you have to do the extra step of adding hypo to the beginning. So hypo, chlor, add the us ending, hypochlorous, and acid. Congratulations on reaching the end of Covalent and Acid Nomenclature Bootcamp 2.0. Huzzah! Before you head off, let's just recap some important points. For covalent nomenclature, remember that your prefixes are determined by the subscripts of the elements and that you don't need to balance charges. And for acids, focus on the oxygens, especially when it comes to polyatoms, and use the right prefix and ending. Now you know all that you need to know for acid and covalent nomenclature. Now go out there and ace the test.